Hello everyone, I'm Malavika Jakata. Today we are going to see about the most important topic, especially for the grade 9th and 10th, that is polynomials and the remainder theorem. Even 8th grade students, you have to know what is polynomials. Before we enter into the topic of remainder theorem, just we have to know what is polynomial. Because polynomial is the base for remainder theorem and factor theorem also. Okay. So just see the word polynomial. Poly is nothing but much, many, more like that. Okay. Nomials is nothing but term. So in mathematical language, we can say polynomials is nothing but many terms. Okay. In upcoming slides, I will tell you what is terms. Okay, or how we find the terms, or how we calculate the terms, and everything. So just we have to enter into the second slide. That is what is polynomial. It's nothing but we can say how we write the polynomial. We have to write the polynomial with the help of variables, coefficients, constants, and operators. Okay. So first we have to see what is variable. So variable is nothing but we have to use alphabets in unknown values. Okay. I give small example for you. My LHS is 4x. My RHS is 8. So calculate what is the value of x here. You can simply say x is equal to 2. Then only you will get 8, right? So it will be very easy to calculate here. Then you say easily that is x is equal to 2. In some places, we cannot find the values. So for that purpose, we use the variables. Most of time we use only a, b, c or x, y, z in mathematics. Okay, so that's why I give an example here x and y, but you can use any variables in alphabets. That is not a problem. Next, coefficients. Numbers multiplied by variables. We already know what is variable. We well known about numbers also. So it will be in the form of 5x, 4x, 7y, 2z like that. Okay, the number will be multiple with the variable. So simply we can say before variable that is known as coefficients. Okay, so you have to tell me 4x, what is variable here and what is coefficients here. Yes, 4 is a coefficient, x will be a variable. Okay, good. Next, constant. Constant means it will be a fixed number. It cannot have a variable. For example, 1, 2, 3, like that. Okay, whatever it will be. But most of the time, we can use the constant in the last of the polynomial. Okay, I will tell you why, then what is the purpose of that. Because polynomials, when we write the polynomials, we always use the standard form. The standard form is nothing but arranging the polynomials with the help of the power. Okay, it is nothing but degree. So in the standard form, we used to write in the descending order, that is the highest number to lowest. Otherwise, we can use ascending order also, but according to the Indian mathematician, for our convenient, so we can always suggest that or always use descending order itself, that is highest to lowest. That it will be depend upon the degree of the polynomial. Okay. So next, see there is a constant. Here it didn't have any variable. Okay. So what has happened to the variable here means the variable power will be 0. For example, 7x power 0. So anything power 0 is nothing but 1, right? So that's why we cannot write the 1 here, because 7 into 1, it will be the 7. So for that purpose, we use the number itself. Okay, fine. The next thing is operators. Operators is nothing but addition, subtraction and multiplication symbols. So here I give one example for you. I think it will be visible for you. That is example, a polynomial with variable, coefficients and a constant. See, the first one is 4x square plus 3x minus 1. Okay. Just see the power of first term. X square, right? Okay, it is the highest power. See the next term, 3x. X power 1. Now see the last, that is a constant, minus 1, x power 0, because the last previous term will be x power 1. So which means the last term x power 0. So anything power 0 is 1. So for that purpose 4x square plus 3x minus 1. Already I told you, right, how to calculate the terms. Just see, here I have three terms. How I say this means it will be depend upon the operations, okay, especially addition and subtraction. The addition and subtraction will it will help us to identify how many terms are there. So with the help of addition and subtraction, I will tell there are three terms, okay. I think 4x square is first term. The plus symbol is there. So the next term will be 3x. The minus sign is there. So next term will be 1. So with the help of the operation, we can identify the terms. Here you see, I write the polynomial in the base of standard form. I use the descending order here. Okay. I think you can get some ideas about polynomial. Because you're already well known about polynomial, I think so. So that's why I give a small intro about polynomial. Okay, next, already I said to you what is standard form, that is mentioned in this slide. I will explain again for you. That is standard form. When we write polynomials, we arrange terms by the power of the variables. Power, the most of the place we can pronounce the power in the form of degree. Okay, remember that we cannot use power because you are not kids, right? So you can easily pronounce that it will be the degree. Okay. uh so especially the degree and power will be differ, but you can pronounce degree will be the most standard form. Okay, so you will see that standard form is always depend upon the ascending order or descending order. So most of them we always prefer the standard form in the ways descending order for our convenient. Okay, so highest power to the lowest power, that is known as descending order. So ascending order is nothing but smallest power to the highest. Okay, I think it will be easy for you to understand this. We already see one example in the last slide. Okay, so now we will enter into the next thing, that is classifying the polynomial. So classifying the polynomial in the base of terms and degrees. Mathematicians devise the classification of the polynomials depend upon the terms and degrees. Okay, so it is nothing but it will be the types. Okay, classification is nothing but the types. Okay, so types of polynomial depending upon the terms. Yeah, see the first one, monomial. Okay, a polynomial consisting of only one term. You already know how to identify the number of terms, right? Here I give an example for you, that is 5x cube. 5x cube is a single term because 5x cube is nothing but 5 into x cube. Okay, so it will be the single term. Remember, the term will be calculate depending upon the operations of addition and subtraction itself. Okay, so here I have only one term, so that's why I says this 5x x cube is monomial. Okay, see the next one, binomial. Okay, binomial, a polynomial consisting of two terms. See the example, 2x plus 3. So here I have the addition sign. So it will be two terms, right? 2x is first term and 3 will be the second term. Two terms are there. So it is known as binomial. Then trinomial. So it will be three terms. See the example, x square, it will be the first term, minus 4x, it will be the second term, plus 4 will be the third term. So here I have three terms, then we can pronounce this polynomial, that is trinomial. Okay, so these three is depend upon the terms. Okay, now we are going to see about the polynomial. It will be classified or it will classify depend upon the degree. Okay, degree is nothing but the power. So just we have to know what is degree and power. Power is nothing but I give one example for you. That is 3x power 2. Here 2 will be the power. Okay, I give another example for you. 3x cube plus 2x square plus x minus 3. Then what is the degree of the polynomial? It will be the highest power of the variable. Okay. Power, we can commonly denote this from our lower class. We know that x power x square or x cube or x power 4, the 4, 3, 2, these are the powers. But degree, especially in the polynomial, we can identify the degree, that is nothing but highest power of the variable. Okay, I think now you can clear about what is power and what is degree. I think that two slides before I told you, we already use power word in the lower class, but we have to mention degree. So this is the reason why I told that. Okay, next, classification by degree. So degree is nothing but highest power of the polynomial. Okay, so see the first one. I have the 7. Okay, what is the variable here? X power 0. So that's why x power 0, anything power 0 is nothing but 1. So 7 into 1 is 7. So here I have the variable. That variable is x power 0. So x power 0, it became 1. So the answer will be 7. So I didn't have any power here, right? The highest degree is 0. So for constant terms, the name of the polynomial is constant polynomial. When you see the constant term, you can easily put equal to constant polynomial. Okay, I give an example for you. 3x square minus 4. What is the power of the constant polynomial is 0. Okay, so I give another example for you, that 7. Okay, I give only one single number. It didn't have any power, which means we can say is it the constant. So it will be the constant polynomial. Okay, the next one is linear polynomial. Linear polynomial, the power of the variable will be 1. So here I insert one example for you, that is 3x plus 4. You always check the degree or power only in the variable itself. Here I have x, right? X is the variable. So just you have to see what is the value of x here as 1. So it will be the degree, because highest power is degree, right? So highest power is 1. We can say it is a linear polynomial. So the second thing is, that is third thing is x square minus 5x. Here you see the highest power. Here x power 2, that is x square is the highest power, right? So that is, it will be the 2. That's why you can say it is a quadratic polynomial. The last example, 2x cube plus 1. Here you have to see the what is the highest power? X cube, right? So x cube means we can say it is the cubic polynomial. Okay, it will be depend upon the highest power of the polynomial. The highest power is nothing but a degree. So remember one thing, the constant polynomial does not have a variable, because the variable power will be 0. Okay, remember this. Okay, then just see this. I think we completed the basic of polynomials. We know what is polynomial and how to write the polynomial, and we can easily calculate the degree of the polynomial, and we can easily write the standard form of the polynomial. And you can write any polynomial because you know the rules how to write the polynomial, and we know the terms. We know the types of the polynomial. The classification is based on the terms and the degree. For terms, we know the name of the polynomial, that is monomial, binomial, and trinomial. And it will be the based on the degree. It will be the constant, linear, and quadratic, then cubic polynomial. I think you are familiar with this. So this is the basic thing you have to know. I think is enough. So we have to enter into the remainder theorem now. Okay, remainder theorem. So before we enter into the remainder theorem, just we have to know what is it. It is just a recap. I think you know very well about this. Okay, so I give one example for you here. See the case 4 divided 2, right? So we can divide the 4 with the help of 2. Okay, so just write what is a dividend, what is a divisor here, what is a quotient here, and what is the remainder here. So for that understanding, I can write here that is a dividend is nothing but 4. So divisor will be the 2. We You have to know what is the name of everything. So for that purpose, I gave here. So dividend is 4, divisor is 2, quotient is 2, and remainder is 0. Otherwise, you can solve this. Okay, you can easily get this. Okay, I think you all know this. Just recap part itself. Division algorithm. So what is the division algorithm? Just we have to know before we enter into the remainder theorem, two things we have to know. The first is I already show the one slide for you, right? The basic division recap. So you have to know the name, that is what is the name of 4 and what is the name of 2 here, and what is quotient and what is remainder you have to know. For that purpose I insert this slide so you know this. So the second thing you have to know before enter into the remainder theorem is division algorithm. Okay, so in the small classes, I think the around 6th standard, 5th standard, they teach you that is dividend equal to divisor into quotient plus remainder. There is a division algorithm. So just you have to take this example 4 divided 2, just substitute here, that is dividend place is nothing but 4 and equal to divisor place is 2 and quotient is into 2, then remainder will be 0. So divisor is 2, quotient is 2 is nothing but 4. 4 plus 0 because remainder is 0. 4 plus 0 is nothing but 4. Here always, sorry, already we have dividend is 4. So 4 equal to 4. LH is equal to RHS. So this is one of the way we have to find the division. So that is known as the division algorithm. Okay. So it will be very helpful for you to understand the remainder theorem. That's why I mentioned here why it is matters. The formulas, this formula form the logic backbone of the remainder theorem. It ensures that every part of the division is accounted for while dealing with the simple integers or complex polynomials function will be used. Okay. So for that purpose, I insert here. So now we enter into the remainder theorem. So just see. So remainder theorem. For polynomial p of x and g of x, normally we denote the polynomial in the form of p of x. If we have more than one polynomial, we can mention g of x or q of x or r of x like that. Here I take two polynomials, one is p of x and another one is g of x. But the degree of p of x is greater than or equal to g of x. So you already know how to calculate the degree of the polynomial. So here the degree of p of x is always greater than or equal to g of x. Okay, just you have to take two polynomials and imagine. So while you writing the polynomial of p of x and g of x, you use this condition to draw this. Here p of x is dividend, g of x is a divisor, q of x is quotient, r of x is remainder. Okay, so already we know that p of x is dividend means we have to divide this value with the help of divisor. You can take any polynomial here. For example, shall I give one example for you? 2 okay, 2x cube plus 4x square plus x plus 2. It will be the p of x. Just imagine the g of x. G of x is nothing but 4x square plus 3x plus 1. So just compare the degree of both the terms. The p of x will be greater than or equal to g of x. Then only we can divide the p of x with the help of g of x. Okay, that's why I told this example for you. Okay, you already know what is quotient and what is the remainder. Just apply one thing. Okay, first, how to write the remainder theorem. If you solve one sum means you have to use certain procedure to write down this sum, right? So if we have two polynomials, we can easily divide this, right? If you have to, for example, if you have two numbers 4 and 2, 4 divides 2 means we can easily solve this. If we have two polynomials, already I told you, right? 4x square plus 2x plus 1, and another polynomial will be 3x cube plus 4x square plus 3x plus 1. So it will not easy to solve with the help of the usual method, right? We cannot use this polynomial to solve the usual method. We can do, okay, the division of the polynomial is there, synthetic division is there, we can divide. But before that, we can easily solve this two polynomials, okay? So that's why they introduced the remainder theorem for the dividing two polynomials and get the remainder of the polynomial, okay? So here you say, first identify the polynomial. So just remember, normally we already know the p of x will always greater than or equal to g of x, right? So first we have to find the value of x for the divisor. Okay, so how to find the value of x? You have to put equal to 0. For example, 2x minus 1 will be the divisor, means you have to put 2x minus 3 equal to 0 and find the value of x. We already know the 0 of the polynomial, right? How to find the 0 of the polynomial? We have to put the polynomial equal to 0 and find the value of x. So I'll tell the example, right? 2x minus 1 equal to 0 is nothing but 2x is equal to 1, x is equal to 1 by 2. So this 1 by 2 is the value of x. Okay, it will come from the divisor. So you have to substitute this x value in the dividend and get the value that is known as remainder. Okay, so just work out some problem, then one will be easy for you. I will explain this content clearly for you. See this problem. 3x square minus 2x plus 2. What is the first rule of remainder theorem? We we must have two polynomials. So here you have to see 3x square minus 2x plus 2. It is a one polynomial. It is will be the quadratic polynomial. Okay, it will be the quadratic polynomial. I say the classification of the polynomial with the help of the degree. Okay, and by x minus 2, x minus 2 is another polynomial. Okay, just check the let value and give the name for that. Okay, let p of x is equal to 3x square minus 2x plus 2. Then q of x is equal to x minus 2. Here x minus 2 is the divisor. Okay, first condition, you have to check whether the divisor is smaller than dividend. Yes, it is smaller than dividend, or otherwise it will be equal to the dividend. It is not a problem. First condition is satisfied, so tick it. Second thing, we have to use the divisor. First, find the value of x, right? So here the divisor is x minus 2. So it's nothing but 0 of the polynomial we have to find. So x minus 2 equal to 0, and find the value of x here, that is x equal to 2. This is the format we have to do in the remainder theorem. Always use the divisor polynomial. The polynomial will be the divisor, right? So polynomial equal to 0, and find the value of the variable. It will be maybe x or y or whatever it is. Okay, that is the second step. First step, you have to check p of x is greater than or equal to q of x. And the second step, we have to find the value of x or y, whatever it is, or variable, with the help of the divisor. So here I find the x value. Now substitute this divisor value, that is x is equal to 2, in the first polynomial, that is p of x polynomial. So I substitute here for p of x, in the place of x I substitute 2, that p of 2 equal to 3. Here I have x square, which is we have to put 2 square, and minus 2, x in 2 into x is nothing but minus 2 into 2 plus 2. So 2 square is 4, 3 4 that is 12, and it's a normal thing, right? 2 2s are 4 and plus 2. Always you multiple the two terms. First you have to multiple the sign. Then you have to multiple the number. Then only you cannot make any mistakes. So then you have to solve the sum. Most of them do 12 minus 4, then plus 2. But you cannot do like that. Always add or subtract the same sign. So here I have 12 and plus 2. So add this both thing, that is 12 plus 2 is 14. Then subtract the 14 from 4, it will be 10. It is the correct procedure we have to do. So the remainder will be 10. So this is the procedure. Whatever sums I gave for you or the school gave for you, first you have to find the degree of, first you have to check the degree, and the second step you have to put equal to 0 for the divisor and find the value of x and substitute the value of x in the p of x polynomial, the first polynomial, and get the answer that will be the remainder. Okay. So definition of the remainder theorem is came from the division algorithm. Okay, fine. So I attached some homework for you. Okay, exercise 1, exercise 2 and 3. So find the remainder theorem when x cube minus 3x square plus 4x is equal minus 2. So you have to take first polynomial is p of x and second polynomial will be q of x, that is x minus 1. If any terms is missing, you have to put 0 for that. Here you have to check the second exercise. X square plus 5x plus 6, there is no problem here. For some sums, for example, 2x cube plus x minus 3, here x square term is missing, right? So that place you have to put 0 and solve this sum. You definitely get the answer. I think this content will be helpful for you to understand what is polynomial and what is a remainder theorem, right? I think you are very good in polynomial. That's why I have tell the intro itself. And remainder theorem is most a simple thing. So that's why I cannot elaborate so much of thing. So just reminder, theorem is nothing but p of x is always greater than or equal to q of x. And it will be depend upon the division algorithm. And you have to remember the rule how to solve the problem and how to find the remainder. Then why use the remainder theorem? Because two polynomials we cannot divide with the usual method. For that purpose, we use this remainder theorem to find the remainder. Okay. So if you ask only the remainder, you can easily use the remainder theorem. If they ask any quotient, you cannot use the remainder theorem, because when you find the quotient, remainder theorem will not help for us. We have to use another method, that is division of polynomial and synthetic division. That will be helpful for us to find the quotient also. For the purpose to find the remainder, it will be helpful for you, the remainder theorem. Okay, for the polynomial itself. Okay, thank you. If you have any doubt, please comment me in the comment section. I will be clear for you as soon as possible. And share your feedbacks if any changes you want. Thank you so much. Have a nice day.